Question 4 says, engineers are running trials on an experimental magnetic levitation train. The train moves in a straight line and all measurements are taken relative to a fixed point P. So here we are, it's moving along, and I'm going to call this here, this point P. This is time is 0. And we're told at time equals 0 seconds, the train is at P. So that's what I've drawn there, time's here. Of course, it's moving along here, yes. And it says, and has a velocity at 2 meters per second. So at t, it's already reached v equals 2 meters per second. So v equals 2 meters per second. There it is. Acceleration, a, is in meters per second squared at time t after the train departs from P and is given by a is equal to 2 plus 0.6 t. So a at this point, we've got a t and a v and an a for the very start. So that's given by 2 plus 0.6 t. 2 plus 0.6 t. Calculate the distance from P when t equals 2 seconds. All right, so we're given the acceleration, we have to calculate distance. So we want distance when t equals 2. So I'll put find s when t equals 2 seconds. All right, so we've got the acceleration. Well, if we integrate acceleration, we'll get velocity. And if we integrate velocity, we'll get distance. Well, let's go ahead and do that. So velocity, so we'll have to take a two-step approach here. So velocity is going to equal to the integral of this, which is going to be integral of 2 plus 0.6 t, which equals, I'm going to increase time by 1, and I'm going to increase time by 1 here as well. I'm going to add a c component to the end. Now here we're told, by the way, at t equals 0, velocity is 2. So if I was to put a 0 in here, this would all equal 2. So let's make sure that's true. So I'll just tidy this up first. So v is equal to 2t plus, this is 0. Half of 0.6 is 0.3 t squared plus c. And we're told at t equals 0, so if I put a 0 in all here, v will equal 2. So here's v equals 2. And I'm going to make all of this 0, yeah? So that's going to be 0 plus c. So c must be equal to 2. So that's the one thing we know, c equals 2. So now I can restate the velocity equation. Therefore, v is equal to 2t plus 0.3 to the power of t to the power of 2 plus 2. So there's my velocity equation. Now we're going to use the velocity equation, of course, to find the distance equation, and we know that the distance equation will equal the velocity equation integrated. The integral of, in other words, 2t plus 0.3 t squared plus 2 with respect to time. Now I could have just said is equal to the integral of v with respect to time, but I chose to write the whole thing out. It doesn't really matter, you can do either. But here, this way I can say, therefore, s is equal to, and I can just go ahead and go 2t, increase the power by 1, divide by the new power, increase the power by 1, divide by the new power, and increase the power by 1, and divide by the new power, and add a c component. And I ask myself, well, is there a c component here? Now, let's take a look and see if there is. I don't think there is actually, no. We're not told anything about the distance. Let's have a look. Right, so at t equals 0, we know velocity, and we know an acceleration, but we do know at t equals 0, there's no apparent distance given. It doesn't say distance is already 5 meters or something, because if it said s equals 5 at t equals 0, then we'd be going down here and adding in a 5 on the end here. But we don't need to do that because there's no such information. All right, so we're told now, so I can now eliminate the c. I know there isn't a c value, but we are trying to find s when t equals 2. So let's actually then substitute in 2. In fact, I'll tidy this up first. So s is equal to, or 2 divided by 2, that's 2 squared, plus this becomes 0.1 to the power of, t cubed. I'll just keep them all in t, so plus 2t. And we now say at t equals 2, although my t is more like kind of a sloping e, s is going to equal, that's going to be 2 squared plus 0.1, excuse me, that's going to be 2, and that's going to be cubed plus 2 times 2. Yeah, and that's my 2 on the end there. Equals, well, 2 squared is 4, plus now 2 cubed is 8, and 8 times 0.1 is 0.8, and then I've got plus 2 times 2 is 4. So I've got 4, and 4 is 8, plus 0.8 is 8.8, and the distance will be in meters. So we know when 2 seconds has elapsed, it has moved 8.8 meters. So it's probably going to be whipping along pretty quickly, I imagine, this train. And that's my solution.